Hello everyone, I am Mrs. Rushali Chaudhary, lecturer, Praveen Patil Polytechnic. Today we are going to learn basic science chemistry, chapter 1, chemical bonding, catalysis. We already started with the bonding. What is the bonding? The relation between the atoms and the molecules, it's called as a bonding. Today learning objective is metallic bonding and a coordinate bond. We are going to learn the definition, formation, how these molecules formation take place, properties of this compound, and multiple choice question based on this. Metallic bonding. Metallic solids are held together by metallic bonds. Metal atoms release some of their electrons to be shared by all the other atoms in the crystal. A metallic bond is different from the covalent and ionic bond. Instead of a bond just between the two atoms, a metallic bond is a sharing of valence electrons, between many atoms of a metal element. Thus, metallic bonding is an electrostatic force of attraction between valence electrons in the form of electron cloud or delocalized electron. Delocalized means just moving here and there, not having the specific position. And positively charged metal ions called as kernels in a metal element. When we are talking about the metals are having incompletely filled outermost orbit. Their valence electrons are less and they are moving in all direction. Here we can see that this is a positively charged nucleus and around is negatively charged electrons. These are the valence electron. And what is the kernels? Inner shells electrons plus nucleus. Due to the inner shell, the kernel is the center part of an atom and it is a positively charged. Metallic bond is described as sharing of free electrons among a lattice of positively charged cations. Hence, all valence electrons belong to the crystal as a whole. These electrons are free to migrate through the crystal lattice, thence giving rise to high conductivity of metals. See here, this is your metallic solid. These electrons are free, so when we are applying the voltage, they are easily moving from a higher voltage towards the lower, and metals are become good conductor of electricity. Properties of the metallic compounds or having the metallic bonding. Metallic bonds are non-directional. Metals shows the property like a luster, malleability, ductility, and electrical thermal conductivity, tensile strength, toughness, hardness are due to the mobility of the electrons in the solid that we are going to discuss later on. The strength of the metallic bond varies depending on the charge and size of cation. So the melting point and diffusion heat of the metal is vary. So they are having moderate to high melting point. Next type is the coordinate bond or the dative covalent bond. A coordinate bond, here it is also called as dative bond. In a covalent bond, sharing of electron take place by the both side, but in a dative coordinate bond, sharing of electrons take from the one side. That is called as a one-sided sharing. Therefore, it is also called as a coordinate bond. The atoms are held together because of the electron pair is attracted by both the nuclei. In the formation of simple covalent bond, each atom supplies one electron to the bond, but that does not have in this case. Here we will observe the ammonium ion. It shows as NH4 plus are formed by the transfer of hydrogen ion from the hydrogen chloride molecule to the lone pair of electrons in the ammonia molecule. See, this is the ammonia molecule which is having a two lone pair of two electrons, one pair is present, and this is your H plus 1. H plus is required one electron to satisfy outer one. But what happened here? They are not sharing this positive charge with the ammonia molecule, but they are sharing two electrons of ammonia with hydrogen. Therefore, it is called as a one-sided sharing. The bond is called as a coordinate bond or dative covalent bond, that is represented by the arrow. In an exam, they will ask you among following which is an example of dative covalent bond compounds. Answer is ammonium ion. Ammonia is an example of covalent compound. Ammonium ion is an example of coordinate bond or dative covalent bond. When the ammonium ion is formed, the fourth hydrogen is attached by the dative covalent bond because only the hydrogen's nucleus is transferred from the chlorine to the nitrogen. The hydrogen's electron is left behind on the chlorine to form a negative chloride ion. Properties of coordinate bond. The bond is rigid and direction. We have to show the arrow from donor towards the acceptor. It is a property of an atom that have a lone pair of electron. If atom is having lone pair of electron, then only coordinate bond is possible. The melting and the boiling point are higher than pure covalent compound and lower than a ionic compound. It is in between the covalent compound and the ionic compound. They are sparingly soluble in a polar solvents like water, but readily soluble in a non-polar solvents. They are bad conductor of electricity. Carbon monoxide, N2O, nitric acid, H2SO4, ammonium ion are the example of coordinate compound. Just solve a MCQ based on this. In ammonium ion, electrons required between hydrogen ion and nitrogen ions are 1. Dative covalent bond is found in ammonia, it is a covalent bond. Ammonium ion, it is a dative covalent bond. In urea, it's a covalent bond. Nitrogen, covalent bond. For dative bonding, one atom having a lone pair of electrons combine with electron deficient compound to form a neutral or to complete the octet. The conduction of electricity in a metallic bonding is due to the presence of proton lattice, delocalized electron nucleus. In a metallic bonding, we will observe that kernels or the positively charged nucleus is surrounded by the free electrons. Due to that free electrons, conductivity, malleability, ductility, these properties are shown by the metals. So answer is delocalized electrons. Thank you so much for your attention. If you have a doubt, you can ask me anytime. You can also mail me your queries on my email address rushalic2111 at gmail.com. Thank you so much.